today we're going to take a look at a spring system and we're going to take a look at the velocity and the position of the spring at a given point in time. I have a motion sensor set underneath it. This is a typical mass spring set. You can see the spring is attached to a hook above, and there's just a mass hanging down. And what we're going to do is we're going to pull down on this mass. We're going to let it oscillate. And while this is oscillating up and down, we are going to take a look at the position and the velocity, and then we'll talk about what we're seeing. So I'm going to pull this down. I'm going to let it go here, get it started. Now I'm going to hit record. Okay, we get a very clean graph of that. Now we could go back in this video in slow motion and analyze exactly where the mass was at any given point in time. In fact, I encourage you to do that so to validate what I'm talking about and showing you here. But as we look at this curve, first off, you notice that we're seeing it's very sinusoidal. Right? You can see the sinusoidal pattern to it. And as this is moving over time, we're recording the position. And so periodic motion is sinusoidal. That's one of the things that we've learned, that we find when we talk about simple harmonic motion. It follows sine and cosine patterns in this periodic motion. But notice something, that when it is at the peak, when it's at its amplitude, we come straight down. The times are lined up perfectly here. We can pull this one over just a tiny bit more maybe, but you could see here that it's almost perfect. And as it comes down, it's at zero. The velocity is at zero when it is at its peak. We've said that to be the case. Then when it gets to the next peak right here, look at this. This would be the bottom. It's at zero again. So it's at zero when it's at the top, and it's at zero when it's back down at the bottom. And as it's oscillating, it's going from zero to some speed back to zero. Now, you learned earlier in the year about graphing the slope of a position time graph. And what you found was that where the slope is the greatest, it has the greatest velocity. And that's occurring in here. And you will see that right here, right in the middle is where it's reaching its peak. It has the greatest velocity, about 35 hundredths of a meter per second. Then it comes back up to the top, 35 hundredths of a meter per second, as it passes the equilibrium point. And so at the equilibrium, you are seeing the greatest velocities, positive and negative, depending on whether it's going up or down at any given point. But if you're looking at this graph here, the green graph, you see that the peaks occur where the position is zero. So this goes along to support our understanding of springs, that when the spring is at its maximum position, it has a zero velocity, and when the spring is at the equilibrium, it has the greatest velocity. The energy conversion here says that it would have the greatest stored spring energy when it has the greatest displacements, and it has the greatest kinetic energy when there is no energy stored in the spring, which is when it's at the equilibrium. If you have any questions, please let us know.